Alright guys, today we're going to be talking about the area of trapezoids and kites. These are going to be a little bit more difficult, so make sure that we're paying attention. I am going to let you guys do a little experiment. If you have time at home, you don't have to do it. You can keep watching to get the formulas from me, or you can try to figure them out yourselves on the next slide. Alrighty guys, so we're going to start off with the area of a trapezoid. Now if you want to experiment and try at home to figure it out by yourself, get out a piece of paper, draw a trapezoid, and cut it out. You may cut out more than one trapezoid to see if you can make it into a shape that we have seen before. Now I do want to say that what's shown on my screen right now is called an isosceles trapezoid, meaning these edges on the side are going to be the same length. So if you were to put them or cut them, you could, it looks like, make it into a rectangle. That is not going to be the proper way to find the area of a trapezoid. So try doing a trapezoid that might not have two equal sides. So if you chose not to pause the video and you did not want to experiment yourself, we are going to go ahead and start now with finding the area of a trapezoid. So very similar to the area of a triangle, we are actually going to double this trapezoid, and it's not going to be perfect, so please excuse me. But pretend that Miss Greathouse is perfect and that that's an exact replica of our original trapezoid. So as you can see, now it looks like a parallelogram. However, it is double the parallelogram. Not only is it double the parallelogram, but these two lengths are not the same. So we're going to label the two sets of parallel lines as base 1 and base 2. Now looking at our second trapezoid that we just drew, it's flipped over, which means this top is base 2 and this bottom is base 1. So if we were to find the area of this parallelogram, I would find the base length by doing base 1 plus base 2. Because in order to make it into a parallelogram, I flipped it over. So I'm combining both of those lengths. But just like in the parallelogram, in order to find the area, I do need to multiply it by the height, which again is going to meet there at that 90 degrees. So I can take that base 1 plus base 2. I can multiply it by my height. But if I was to do that, that would find the area of this entire parallelogram. I only want to find the area of half of this parallelogram. So in order to do that, I can multiply that final answer by 1/2, divide that final answer by 2. You could do 5/10. I told you this before. But that's going to be your equation to find the area of a trapezoid. You're going to add both of the bases, since we're going to double the shape to make it into a parallelogram, multiply it by the height, which again meets that base at a 90-degree angle, and then we're going to cut it in half since we did originally double the shape. So here's an example of another kind of trapezoid with base 1, base 2, and the height all labeled. You can see that the height meets there at that 90-degree angle, just like we want. So I know that if my formula, which is written right here, it's going to be half of the height times both of the base lengths. Both my base lengths are 8 and 6. So you can combine 8 plus 6. Then you need to be able to multiply that by 10 and then take 1/2. Now, if you look at the way that they solved it in their steps that they used, they started with dividing or by multiplying 1/2 times 10. Now, it doesn't really follow order of operations. I kind of did 2 steps at once, doing 8 plus 6 to get that 14, and then doing the 1/2 times 10 to get that 5. You can follow order of operations. You can multiply just the height by 2. Because we're working with multiplication, it really does not matter what order you do it in. You should get the same answer no matter what. All right, so now we're going to talk about the area of a kite. And because kites do not have any parallel parallel sides, it is going to be a little bit tricky. However, I want you to think about the way that we've manipulated triangles and parallelograms and trapezoids to find their formula. And we're going to do something very, very similar here to a kite. What we're going to actually do is we're going to go ahead and we're going to enclose our kite in a rectangle. So we're taking all of the sides, we are connecting it at right angles, therefore creating a rectangle. Now, if you did this with a piece of paper, here's what you would find. That all of these areas on the outside that we just created is going to be equal to all of this space inside the shape. So again, I've just doubled my shape. But now I don't know this length right there, which we usually use to find the area of a rectangle, which we call our base. However, I can find that by connecting the diagonal line from opposite vertices. I can do the same thing for my height on this side, connecting these two vertices up and down. So if you can see right here, they are going to meet at that right angle. So what we would normally call our base, I'm going to call diagonal 1. What I would normally call my height, I'm going to call diagonal 2. Given that information, you should be able to figure out by now that to find the area of a kite, I'm going to have to do half, take half of it, now we're at the end, half of the diagonal 1 times the diagonal 2. Now it's very important that those do go in parentheses. However, you could do it out of order since there's an invisible multiplication sign between the 1/2 and the parentheses. You would still get the same answer. So you're going to use those diagonal lengths and what we just showed you with the manipulation of the kite to find the area of a kite. So here's just a quick review for a kite. Remember that a kite has two pairs of adjacent sides congruent, meaning the same length, but it does not have any parallel sides. So it was a little bit trickier finding the area, but I can take my diagonals, multiply them together and divide by 2 or multiply them by 1/2 in order to find the area of that kite. So I hope that you've learned a little bit more about finding areas of trapezoids and kites. I believe we've covered all the quadrilaterals as well as triangles now at this point, and that's really all that we're going to do with finding the area. So make sure that if you have any questions, you put them on Google Classroom, and you can now go do your 5-question Google Classroom homework.